prime numbers. You probably remember that term from math class, and maybe it felt a little abstract, a little hard to connect with. Well, what if I told you there's a completely different way to look at them? We're going to toss out the old textbook definition for a minute and find a new way to think about these amazing numbers. So get this. What if the whole secret to understanding prime numbers wasn't really about division and factors, but about something we all get, something we've been doing since we were kids? Sharing. Just thinking about it this way, it changes everything. All right, let's dive in. We're going to reframe this whole thing as the sharing problem. We're basically building a new, much more intuitive definition from the ground up, and we're going to use stuff you can actually picture, not just formulas on a page. Okay, so this is the classic definition, right? The one you'd see written on a blackboard in school. And look, it's 100% correct, technically, but it doesn't always click, you know? It tells you what a prime number is, but it doesn't really help you feel why it's special. So let's just push that textbook definition to the side for a moment. We're going to start thinking in terms of real-life distribution. Seriously, just picture it. You've got a handful of biscuits, or maybe some pencils, and you want to share them with your friends. So here it is, our new rule. A number is prime if you simply cannot share it out equally among two or more people, with one little catch. Each person has to get more than one. That's it. This one simple idea is the only tool you're going to need. Now, the fun part. Let's actually put this new rule to the test. We'll just run through a couple of quick examples, and you'll see exactly how this works. All right, first up to the plate, the number 7. Just imagine you've got 7 delicious biscuits sitting in front of you. Simple enough? Now here's the challenge. Can you do it? I mean, really think about it. If you try to share 7 biscuits with a friend, one person gets 4 and the other gets 3. That's not equal. What about 3 friends? Nope, that's not going to work either, unless you start breaking them into crumbs. And the answer is no. It's just not possible. And because you can't share 7 things fairly according to our rule, it passes the test. 7 is a prime number. It's a number that just refuses to be shared. Okay, next case. Let's try the number 8. So now we've got 8 pencils on the table. So same question. Can you figure out a way to share these 8 pencils equally among 2 or more people, remembering that everyone has to get more than one? Take a second. Yes, absolutely you can. It's easy, right? You can give 4 pencils to 2 people, or you could even give 2 pencils to 4 people. Because fair sharing is possible, the number 8 is not prime. We call it a composite number. See how much clearer that is? Now, there is a tiny but super important detail in our rule. That little phrase, more than one. Let's zoom in on that for a second because it's actually the key to the whole thing. This more than one rule is so crucial because it closes a potential loophole. Think about it. If we didn't have that rule, you could share 5 biscuits among 5 people by just giving 1 to each person. And if we allowed that, then every number could be shared that way, and the whole idea of a prime number would be totally meaningless. That's why we have to ignore that one for you scenario. And this is exactly what makes the number 2 so unique. So let's ask the question, can you share 2 things so that each person gets more than one? Nope. The only possible way to share them is 1 for each person, and our rule says we ignore that. And that simple bit of logic is why 2 is not only a prime number, but it's the smallest one and the only even one. Okay, so we've been having fun with biscuits and pencils, but now it's time to connect this all back to the formal world of mathematics. This is the aha moment, where it all clicks into place. Check this out. It's a direct translation. When we say a number can be shared fairly, all we're really saying in the math world is that it has factors other than 1 and itself. And when we say a number cannot be shared fairly, you guessed it, that means it has no other factors. Our real-world analogy matches the math definition perfectly. It's the same idea, just said in a way we can all understand. So what's the big idea here? What should you take away from all this? It's really about having a new mental model, a new way to think about and understand what prime numbers really are at their core. I just love this way of thinking about it. Prime numbers aren't just some abstract concept. You can think of them as being kind of stubborn. They're the numbers that fundamentally refuse to be shared fairly. They're the individualists of the number world. So here's your new tool. From now on, whenever you come across a number, just ask yourself that one simple question. Can I share this fairly? If the answer is no, then congratulations, you've just found yourself a prime number.